Welcome to day 2 of MIPI DevCon 2020. We're glad to have you back. Feel free to interact with the presenters and attendees by using the engagement tools at the footer of your screen. Use Q&A to engage with the presenters and group chat to communicate with attendees. You can minimize and maximize each icon by simply clicking on each icon. To view the agenda and see the sessions and demos for today, click on the call to action icon. Enjoy the conference.
Hello, my name is Nicolas Pitre. I work for BeLibre, and for this presentation, we'll do it with some special way because I'm actually visually handicapped, so I have some challenge working out the slides and so forth. So I'm joined by Derla, who will help me through this presentation.
Thanks, Nico. What is Linux? What does Linux refer to? A complete system, an operating system, a kernel.
And that's one thing we need to clarify, because Linux is a wide-ranging word because it refers to so many things. When we talk about Linux as a system, people will say, I'm using Linux. So it's usually the whole system compared to I'm using some other environment. And if we go down the definition more precisely, Linux might mean a distribution. So it's a different flavor of Linux. For example, we can have Red Hat, Ubuntu, and all those different things. And people might not know, but Android is based on Linux as well, because, well, actually, Linux is also a kernel. So in the case of Android, it's using the Linux kernel, which is the very center part of the operating system. And for today's presentation, that's what we're concerned about. We will talk about the I3C HCI driver for the Linux kernel.
Linux development is organically grown, not designed, driven by code contributors, not dictated by anyone in particular, and peer-reviewed in the open.
That's one thing which is special about Linux when we compare it to traditional software environments. So let's say if we talk about Windows or some other proprietary operating systems. In the case of Linux, everyone has access to the code, source code, and everyone is allowed to modify it as well. So that's a big difference with other operating systems.
Thanks. Linux is a compelling choice. Larger developer community, best looked after network stack, extensive storage options, scalable from embedded IoT device to supercomputers, all around very popular and widely used.
Yeah, so that's why since Linux is so popular and used in so many areas, it's often used as a reference platform as well as an actual deployment for product and project and so forth. So it really makes sense for MIPI to provide a driver for the I3C HCI specification at this point.
What is Linux? Linux is an untraditional choice, freely obtainable, freely modifiable, but modifications to GPL licensed source code must be made available. People contribute their changes back to the main Linux to simplify their GPL applications, to lower their maintenance costs, and to benefit from Linux's distribution channels.
That's one thing about Linux. If you want to modify it, Per the GPL, which is the license used for Linux, you need to make your own modifications available to the wider community if you do distribute those changes in any form. So what people do is they simply contribute back their changes to the upstream source tree for Linux. So if you do have a new driver or any support for your hardware, it's the best move is to just contribute it back, and then it gets distributed everywhere Linux is deployed.
Thanks. The MIPI I3C host controller interface, standardized interface between software and hardware, allows for common software driver, reduced software effort, sharing the cost of non-differentiating development.
Yeah, that's one good thing about a standard interface for I3C. So MIPI is driving this specification for the I3C HCI, which is the host controller. That means that everyone with a compliant implementation will benefit from the same software effort, because one driver could drive them all. It's the same strategy that has been used for USB, for example. Many different implementation using the same software interface, which reduces costs and allow for easier maintenance as well.
The I3C HCI specification is comprehensive, extensive, versioned.
That's one advantage of having a standard specification, is that many people are working on it, and every scenario, every use case is being considered in the specification, so it can accommodate all of them in the most efficient way possible. And because it has a different implementation, and it can be revised, so that's why it's versioned as well. So it's really nice to have this effort being gathered at the same place with the central point.
Okay. Comparison between existing drivers and their current state. And there's a table here that shows the lines of code for the various I3C host controller drivers.
Yeah, here we can see that the currently in Linux there are a few host controller drivers, and the MIPI one is quite larger. It's about 2.5 larger than the next largest driver. And this is because the specification is very extensive. It has many capabilities, things that are either not supported or maybe not implemented in the other drivers, like DMA support and a lot of performance-oriented implementation in there. So that's why we can see that the driver is currently quite large.
Right. Yet support is still incomplete. Some of the unsupported MIPI I3C HCI features are auto commands, scheduled commands, master role handoff.
That's one issue with the current Linux I3C subsystem. It gathers to the simple needs of what's being used at the moment. So that's why those I would say advanced features of the MIPI HCI driver is not implemented yet, because the subsystem is lacking support for those features.
The subsystem structure is comprised of 3 layers: host controller, hardware, I3C subsystem layer, common, and device drivers or function drivers.
And that's the way things are being separated in the Linux architecture for I3C. That way we can split out different roles. So the hardware part where the MIPI HCI driver lives. There is the central part where everything is being tied together, and the function drivers. We'll have a look at each of them individually in the next slides.
Okay. So the hardware drivers discovers and initializes controller hardware, implements hardware abstraction for the I3C subsystem, performs low-level requests from the I3C subsystem, and signals hardware events to the I3C subsystem.
Yeah, that's where the connection with the hardware implementation is made. So the role of the driver, the MIPI I3C HCI driver, is to do those things and probe the hardware and implement the abstraction to communicate with the middle layer.
Okay, so the common layer manages registration of host controller and function drivers, collects information about discovered device and configures them, connects device instances with appropriate function driver, and provides a library of helpers for common driver tasks.
Yeah, that's where the things are being initiated. So the middle layer would ask each hardware driver if they did detect some hardware they drive, and if so, it will start the probing of the bus for devices, and every devices that are being discovered will be configured with their own dynamic address and then matched with one of the registered function driver that we'll look in the next slide.
Okay, so the function driver concerns itself with functionality of a single device, camera, storage, etc., is a host controller agnostic, gets involved only when matched to an actual device instance by the I3C subsystem.
That's it. That's where the things make sense from a device point of view, because that's where the actual devices are being supported. So those drivers are being involved through the middle layer, so they don't have to know on which host controller they're running. So every driver at this level should be able to work with any of the host controllers. And the problem that we have right now in Linux is that there is only one single driver for an EMU sensor. And that driver has very, I would say, very simple needs. It only has to read and write some registers at a low frequency. So that's currently a problem, as we'll see on the next slide.
Okay. Function driver interface currently provided by the I3C subsystem. Register, unregister for a device, perform private read and or write data transfers, registering for receiving IBIs.
Yeah, so as we can see here, we can do private reads and writes. We can register for receiving IBIs, but that's about it. So if we want to support the more advanced functions of the MIPI HCI driver, we need to extend this part to allow function drivers to request all those advanced functions.
Needed extensions to the Linux I3C subsystem. IBI interface extension for auto commands, interface for scheduled commands, allow for timestamped IBIs, device private CCCs, bus mastership handing off handling.
Yeah, those are the things that are missing from the subsystem API that will allow to support the missing HCI functions as they were listed earlier. And for those things, there's a condition in Linux that is, maybe we can switch to the next slide. That's where we'll talk about it.
Okay, yes, it's the common wisdom with regards to Linux development. So there's no stable APIs in the kernel. A new API must have at least one entry user. Never over-engineer an API because there are no stable APIs in the kernel.
Right, that's the case. So that's why, since we have only one function driver in the Linux source tree, that's the single user we have for the current API. So we really need to have more advanced function drivers to show the need for the advanced features. And at that point, we can extend the API. And unlike traditional systems like on Windows, for example, where the driver API is being designed upfront to cater to all possible situations, the Linux way is really to just have the minimal API and extend it as needed. So in most Linux releases of the kernel, there are at least one or more APIs that are being modified. So it's not stable. It is extended as the need appears. The thing is, we need to use those APIs because otherwise the Linux community won't accept those changes if they are not accompanied with at least one user that shows how to use those APIs and how they're being managed and so forth. So that's one thing that needs to happen here, is to extend the APIs with the needed functionality and send those changes upstream, because if one driver needs a particular API and that API is being modified afterwards, then the people changing the API will change the driver code as well. So that's why people are submitting their drivers and some contributions to the upstream kernel, just to have this being taken care of automatically.
All right. So in conclusion, considerations for future work. The MIPI I3C HCI driver's core structure is done. Further HCI support requires I3C subsystem extensions. New I3C subsystem extensions require example usage from function drivers, and more function drivers are sorely needed.
Yes, that's the key point here to take away, is that without more function drivers, it's really hard to show the need for extended APIs, and without those extended APIs, it's really hard to implement the more advanced function provided by the MIPI I3C HCI specification. So it's really one thing is influencing the other. So that's like a call for everyone out there. If you do have an implementation of an I3C device and you would like it to be supported in Linux, please do contribute either with source code or with IDs and conversation on the I3C forum for Linux. It's all open, It's public, so please contribute, and this way we can progress the I3C support for Linux by showing interest and the need for further development here.
Okay, so I guess that leaves us open for questions. Thanks, Nico. Appreciate that. I encourage questions to come in via the Q&A pane. Please do so. Meanwhile, we have a few questions. First question is, can we see the current MIPI HCI driver source code somewhere?
Yes, the code was posted on the Linux I3C mailing list for review, so the September archive of that mailing list is publicly accessible, and the code is all there.
Very good. Thanks, Nico. Next question. Is the Linux I3C driver usable on Android as well?
Of course, because Android is actually using the Linux kernel as its core, it benefits from all the Linux drivers as well. So by having the HCI I3C driver and all the I3C device drivers being incorporated into Linux, they will benefit Android as well.
Good. Next question. What is an auto command?
The auto command is a command that the HCI driver will send. It's usually a read. It will send automatically upon receiving an IBI with some filtering. So if you have some asynchronous read to perform, you can set an auto command that will trigger automatically upon a signal from the device.
Okay, next question. Would the MIPI driver make the vendor-specific drivers redundant? Are there no special sauce in the vendor-specific drivers that make them required for their IP?
Well, there are things that are common to everyone. So if you have a special implementation, there is nothing that prevents you from having the interface with the hardware being standardized. That being said, the HCI specification allows for vendor-specific extensions. That if it's not part of the specification and you want to have a special function, then you can implement it through that vendor extension.
Okay, and next question. How can someone contribute a driver for Linux I3C?
In the case of Linux, the best is probably to subscribe to the I3C mailing list and start a conversation there. Then you can expose your plan and your driver, and the people will start a conversation with you about your driver and the best way to contribute it.
Good. You see some more questions coming in. Has there been a particular platform that the source code has been tested on?
Right now, the only platform that I have is FPGA based. So it was tested on an ARM 64 host. Eventually, I will test on other implementation as well, such as test hardware that I received from Intel.
Thanks. And how can someone contribute a driver for Linux I3C?
As I said with the other answer, the best is to just submit it and start a conversation on the I3C mailing list.
Very good. Thank you, Nico. I don't see that there's any further questions in our Q&A panel. Would ask if there's any more. Otherwise, we could end this session, and if any more questions do come in, we will get to those post-event and respond back to you. So as of right now, there's no further questions. Thanks again, Nico, and thanks again to the audience for joining. I encourage you to go to the Engagement Hub and check out the agenda to see what's coming up. We have some more sessions and some more demos. Thanks again, everyone. Appreciate it.
Thank you.